Morning, class. This is the quadratic formula word problem. So here's the problem. Somebody is standing on a really tall hill and they throw a ball high into the air. And the question is, when is the ball at the highest point and how high is it above the ground? And then when does it hit the ground? And here, if I was to draw a little picture, oh wow, this is going to be good. So there's this little person standing on a cliff, and they throw the ball up into the air. It's going to get a highest point, and then it's going to hit the ground. All right. And this models out as a parabola. So you'll have to hit pause on this video, or maybe you showed up to class, but maybe you couldn't. Yeah, so whatever. All right, so that top formula, this means height in feet. This is gravity. Gravity always will be pulling this ball down to the ground. 32, this is the number of feet per second that the ball is thrown into the air. So if there were no gravity, it would keep going up 32 feet every second, but gravity will pull it down. And you are on a very tall hill, or actually a cliffside. The maximum of this little parabola-like thing is right there. And that vertex is the maximum height at the maximum time. And to find the vertex, we just do our vertex formula. X equals negative b over 2a. You can stop this and see that I calculated it to be 1. Then do the Chryslip line, and we find the vertex. And this means at 1 second, the maximum height was 371 feet. So this was 1 second away, and it was 371 feet. Now we're going to find out when it hits the ground. Morning. So to find where it hits the ground, that would be where the value of your x value and the ground, if you think of it, the ground, you're going to be at 0 feet above the ground. So we're trying to solve the quadratic equation using our height function right here with time and feet, and a, b, and c, and I'm not going to go over the whole quadratic formula again, but there you will see, using the quadratic formula, and I get an extraneous answer. The first answer comes out to be about negative 3.82 seconds. That does not work in this real-life problem, and what it would be is if the parabola was continued over here in parabola-ness, which it is, that would be negative 3.82 seconds, but here where it hits the ground is 5.82 seconds. So, once again, height in feet, gravity, initial velocity, height above the ground, finding your vertex by doing the axis of symmetry first, will get you your maximum height at what time it's at the maximum height. And the quadratic formula will get you when it hits 0 feet above the ground or hits 0. The little approximations, these I'm going to allow approximate. So here, if we go to the hundredths on that square root, that is great. Good job.